Hi everyone, welcome to session 24, Origins of Complex Behavior, the Columban Simulation Project. Back in 1983 in the fall, I had made a very important decision in my graduate career to leave Gainesville, Florida, of course staying with the University of Florida, but I got a chance to move to Boston, and it was a great time to actually live in Boston. I got an opportunity to get there and watch the Boston Celtics back when Larry Bird was in his prime. It was very, very cool, very nice thing to do. It gave me an opportunity to actually do my dissertation in downtown Boston, working with persons with visual handicaps, visual impairment, and so on. And also gave me an opportunity while I was in Boston to actually work with Robert Epstein. I had joined Robert working at the Cambridge Center for Behavioral Studies, which is an advanced studies institute, in which it was about 1.5 years up and running, and got an opportunity to work with him in the offices there and really watched the development of that organization to really start taking off. They started gaining all kinds of people in the advisory board and the board of directors, and it was a good time to be with Robert and working on that project. But I also got to work with him on these research projects on creativity. In fact, that's something that you're going to be seeing shortly, a film called the Columban Simulation Project, in which some of this work was first introduced to the general public. In that study, he did research on verbal behavior with Skinner, the Jack and Jill study. It's described in the Pearson Cheney book. And he also did experiments on studying where self-awareness might come from, where insight might come from. I had come into the project already after some of this work was done, and he was just actually finishing, when I got there, some work on tool use in the vision. But I became really fascinated in working on these projects. In particular, I was always interested about things such as novel behaviors, creativity, inconspicuous sources of control over behaviors such as private events. So really got a chance to see some of these important questions brought into the laboratory. And what I want to do is share with you a little bit about the idea of simulation research and its place in science, in particular science of behavior, and then just kind of turn you loose and let you watch the Epstein-Skinner tape. So I'm going to go here and freeze the camera. Excuse me. Okay, and let's get started. So some of the complex behaviors that Epstein and Skinner were actually interested in studying were things such as, thinking and feeling, which is one of the central topics in radical behaviorism, something we'll talk about in the next last two sessions. And also non-traceable behaviors such as self-awareness and language, these things being very, very difficult to study. Also, things that we ascribe to the concept of memory, which is really nothing more than behavior that's controlled by temporally removed stimuli. How do we actually study that in the laboratory? You're going to actually see in the simulation with the Columban Simulation Project a situation in which a pigeon actually learned to use memoranda in order to effectively change or increase the rate of its accuracy of being able to see something behind one curtain and then turn around and come over and make the proper response. And when it became apparent that behavior started breaking down, the pigeon spontaneously began engaging in behavior which actually appeared to be as if the pigeon were taking notes to remember what it had just seen. Again, that's just a layperson's way of describing what's going on, but you're going to actually see where this process takes place. And that really leads to this notion here of novel behavior and this thing that we call creativity. This is something, obviously, that I said interests me, and it certainly interests Epstein in terms of how do we study something like this. These are very, very complex kinds of behaviors. Well, one thing that we could do is bring it into the laboratory and study it under more controlled conditions. In these instances, we see that simulation has actually served not only the behavioral sciences, but it's also clearly served the sciences in general. Certainly, the field of chemistry and physics and biology have used simulation research for a very long time. And in situations where it becomes a little bit difficult to actually bring these things into the laboratory and study them under very controlled conditions, we actually are now able to use computer simulations. For example, we will use simulations to understand the weather, and there are certain computer models that they use every year by the hurricane centers that are able to track, hopefully, what the model might look like in terms of where most of the hurricanes may show up. Will it show up in the Atlantic? Will it come up the Gulf? How many might actually occur? What the paths might be, and so forth and so on. The same thing holds true in us trying to use computer simulations to understand things that we really can't bring into the laboratory. Astronomy and questions about how the moon and the planets actually work. And we could also bring aspects of human behavior into the laboratory, such as computer simulations of war or warfare, how people might actually do computer simulations of famine if something happens where if there are environmental changes that will affect how crops are affected in a particular area. We could possibly determine through computer simulations how what may happen in terms of famine and disease and things such as that. We also are able to look at simulations for determining the melting of the polar regions as well. Again, so we see that simulation has been extremely useful in the sciences in general. So it makes sense that why not take a look at animal behavior and try to study things under controlled conditions and see if we can make sense out of where some of these complex behaviors may come from. In other words, we're really doing nothing more than the experimental analysis of behavior. And just as we studied things which were tricky to study early on, such as operant behavior, we've reached a point now where we could start looking at much more complex pictures of behaviors and where these things may actually come from. We've used animal models in the past in determining, for example, possibly drug and alcohol abuse and other behaviors such as compulsive behaviors, impulsive behaviors, and so on. So the question really becomes, if we're going to use it to study for humans, we have to take into consideration some of the things here in terms of plausibility. In other words, some simulations are better than others. And the things that simulations have to take a look at are specifically its generalizability. That is, whatever you're bringing into the laboratory, can it be generalized to Homo sapiens? Of course, if the concern is, how does this affect Homo sapiens, these things such as creativity? Similarity of the topography of behavior, that is, whatever you're studying in the laboratory, the form of the behavior, remember topography is form, the form of the behavior, does the form appear to be similar to that in which we see with humans? Third, similarity of function of behavior, that is, are the functional relationships the same? And I think when you read the Pearson-Cheney books, those are always the question, and there are certain criteria that are used to determine both form and function of the behavior to see whether it is actually similar. We also may look at structural similarities between the different species. And then finally, Homo sapiens have had the same experiences identified. And again, how much evidence is available that we know that we see something in the laboratory and we could suggest that if this happens in the laboratory, we have reason to believe that there's evidence that this probably happens in the real world many, many times. Okay, so we take these things into consideration, and obviously the type of simulation that's able to address most of these, if not all of these issues, are the ones that actually become simulations that gain most attention in the sciences. So if we were going to bring a topic such as creativity into the operant lab, first of all, we are oftentimes met with a problem in terms of the traditional use of creativity. And here again, the way we use the term creativity in our own language and in terms of psychology is oftentimes has a tradition of mentalistic or cognitive terms. In other words, these things emanate from within. That is, creativity is a thing which is somewhere inside the body, and perhaps it's called upon at certain times, or we bring it to the surface and express this creativity in some way or fashion. It may be perhaps in some form of art or music or some other way in which this creativity so-called comes out. The problem here is then, like everything else, where does it come from? How do we explain the origin of these things? And in that sense, once we just simply identify something inside called creativity, how does that lead to external operant behavior? These become problematic. And in fact, creativity oftentimes is interchangeably used with terms such as inspiration. And the word inspiration is actually an interesting one. Inspiration is very close to the word respiration, which we all know means to breathe, which means that the word inspiration usually translates into that the idea or the action was breathed into the person, inspiration, and that is what actually results in the behavior. Because one of the interesting things about creativity is that we don't know the origin of it. A lot of times if we know the origin, by definition, it doesn't seem to be creative, right? Creativity just seems to come out of nowhere. I mean, we know it comes from somewhere, and we assume it comes from inside the person. But the thing here is that behaviors that we are able to see conspicuous control over, we are more hesitant, I should say, to use terms like creativity. In other words, we have to look at the fact that the verbal community, the people around us, judge behavior. And they say this behavior is creative, that behavior is not. So the thing that's interesting here is that if we are going to understand something about creativity and be able to bring it into the laboratory, we can't look at what people think it is, that it's something inside the organism. Instead, we may look at the conditions under which the verbal community calls something creative versus calls something not creative. In other words, instead of addressing why we have creativity, we look at the verbal conditions under which the response to the word creative is used to describe a certain set of behaviors. And these are some of the instances in which we will use this particular word. For example, the behavior is somewhat deviant, or it's a variation. That is, this is a behavior that somebody does that nobody has really done before, because if somebody did it, then by definition it's not really creative. Now, it could be a variation on a basic theme, and hence, once again, variation. In other words, we always come back and say that when we're going to use the word creative, it seems that we use it specifically to behavior that has not been emitted by any one person or the verbal community. And in particular, if the verbal community identifies it as useful to the community in some respect, that it somehow is useful in society, verbal community, even more so we will say that's creative. Secondly, it is behavior that's oftentimes particular to one individual. That is, a group of people are not necessarily creative, although you could have a creative group, perhaps, maybe you could say that a rock group is creative, but it really is individuals in that group who are creating, who are actually working on particular things. And we say that behavior is particular to one individual. That is, if again it is creative, then it shouldn't be seen by many individuals. It actually emanates oftentimes from one individual. Another condition is that it seems that we use the word creative, and it's inversely related to the conspicuous of controlling variables or the number of individuals emitting the behavior. In other words, what are the likelihood that we're going to call something creative? Well, the less conspicuous the controlling variables, that is, we can't say, we have to say, I don't know where that behavior came from. And secondly, we don't see a lot of people doing that behavior. So these are, again, the conditions under which we use the term as a culture society in particular. In this sense, we are actually starting to get at some interesting functional relations. And by the way, this topic right here is treated quite extensively in Beyond Freedom and Dignity, and you'll see this on some of the exams. This is a very important variable in understanding under certain conditions why it is that we always have to resort to mentalistic and cognitive explanations to describe people's behavior. And that too follows the same general observation. Our using mentalistic terms such as creativity, inspiration, and so forth and so on all come from this idea that the less conspicuous the variables, the more likely it is we will actually ascribe these causes of behavior to something happening inside the person. Now, one of the most important things here in looking at this is that we have to step back from the word creativity and instead look at the word novel. Because these things that we're describing up here are really features of things that we call novel behavior. That is, novel behavior is easier to classify in a laboratory because novel behavior must be emitted before it could be actually judged as creative. Now note here is that you could have behavior in our culture that's deviant, particular to one individual, that we see that it's don't know where it comes from. It's novel in the sense that nobody does it, but quite frankly, it could be extremely dangerous or detrimental to many individuals, cultures, and society. In that sense, it's a novel behavior, but it really is judged as that's not creative, that's outright dangerous, and it's something that we may want to, do something about. Because if many people started to engage in certain kinds of these novel behaviors, it might actually lead to something which could be detrimental to the culture and society. So in that sense, novel behavior is important to study whether it results in something we describe as creative or whether it's described as something that's destructive. We should still try to understand where these behaviors come from. All right. And then finally, when we bring these things into the laboratory, what we are really doing is we are trying to provide a more complete analysis by isolation of variables. In other words, simulation research is nothing more than the experimental analysis of behavior. But in some ways, it's very different than what we call the functional analysis, or what we have talked about previously, single subject design. One of the things that always struck me as interesting is that we really weren't in a very good position to study some of the things that Epstein and Skinner were looking at in the laboratory in a single subject functional analysis, because the simulation research gave us an opportunity to discover. I mean, that's one of the really cool things that you step back and look at that you're going to see here in their research. They didn't know where things were actually going. And all of a sudden, they started to see the emergence of novel behavior. And again, the novel behavior is this. They would teach one thing, teach two things, maybe teach three things, and then the merging of these behavioral repertoires came together in very conspicuous ways. In other words, what Skinner and Epstein did was to take inconspicuous sources of control, bring it into the laboratory, and make those sources of control more conspicuous. And in doing so, they stumbled upon something that we've known about in the research called resurgence. And Epstein did a lot of research based on a lot of the simulation stuff, which really was functional analysis. That is, he was able to isolate not only what experiences were important in determining the outcome of these novel responses, he also noted that a certain kind of history of reinforcement actually didn't lead to a creative response. It almost led to actually what looked like trial and error. But when you actually change the training procedure, it actually now looks like something that appears to be insight or spontaneous tool use, something different than just trial and error. It actually looked like the emergence of creative behavior in every respect. The only difference here is that we know the variables that are ongoing, and you're going to see them reveal how these behaviors come about. So, without further ado, I would recommend that you now go to the DVD recording and watch the Epstein and Skinner recording. I want to also just alert you to that when you actually put this recording on, it takes about 2 minutes before it comes on. I don't know why that is. It's just like a long lead-in to the actual thing. So when you actually hit play, please don't go, whoa, where is it? It's not coming on. Something's broken. Just stick with it. Hit the play button, kick back and relax, and little by little, you'll see that it'll appear, and it's about a half hour long. Till then, after this recording, I'll see you, and we will discuss Sidman's work on equivalence. Take care.